Okay, so today we're going to do a quick SQL review. We will touch on constraints again. We'll talk about entity relationships through an example. So for today, we're going to build a small school database, which we've done versions of. Okay, so today will be also collaborative. So if you guys want to shout out things, please feel free. I might call on some people too. Okay, so let's start by just thinking about what tables we would want. So I think at least step one is to have students. So a students table, what kind of things would we have here?
Name.
Okay, name. I'm gonna do first name and last name separate. Okay, first name, last name. These could probably be what type?
Varchar.
Varchar, okay. All right. What else? How can we uniquely identify a student?
I was gonna say maybe an ID first.
Okay, so let's do an ID. What type should we have this ID be?
Serial primary key.
Okay. Serial, and then yeah, I don't know why. Okay, I think because I didn't write it in all caps, it looks weird to me. Serial and then primary key. So what does the primary key do?
It makes sure that, or is that serial, that each ID is unique? Or am I getting the two mixed up?
No, it is true. So when a field is a primary key, it means that it is unique. It becomes the identifier, the unique identifier for that table. What does serial do?
It increments every time there's new information put into there.
Yeah,
It increments it by one.
So under the hood, when you use serial, there's a function kind of, or there's a separate table that kind of holds what the next ID should be. So when you don't have any entries in your table, I think it starts at 1. I'm not sure of which, like if it starts at 0 or 1 or 2, or yeah, you're either 0 or 1. But every time we insert into the table on the back end, Postgres automatically updates that value. So that's how it kind of keeps track of what ID we're at. So if you've ever noticed, if you do some inserts and then you delete the entries, and then if you insert again, the IDs don't start again from 1. They might just continue on from whatever the last ID was. Okay, so we have ID, first name, last name. Let's do maybe birth date. And this one, what type could we have it be?
An integer.
Date without time.
We could do, yeah. So integer could work, but there's a better one that we could use, and it is date. So there is an actual data type. So let's press data types. There's a long list of data types that we've only covered a portion of. But yeah, so there's numeric types. So you have your integers, your floats, serial, and then you have character, binary, date, time. These are pretty interesting. Time zones, all that fun stuff. I'll keep that open and I'll put it in the docs. Okay, so we can have birth date, and let's say each student has a locker. So, okay, let's actually. So a locker would probably have multiple pieces of information. So, should we put it in the student table, or should we make a separate table for it?
Separate table
Separate table?
with maybe the code, the block, what do you call the twisty thing in the front of it?
Sorry, say it again?
The code to open it
Combo.
Yeah, the combination, yes, exactly.
and its location, what floor of the school or what part of the school.
Yeah, so we can have an ID, combination, and maybe number. So each locker has a specific number. So this number can be an int, integer, ID, maybe same, serial, primary key, combination. What should combination be?
That'd be an integer, right?
Sometimes I guess it depends on the type of lock. So if we are not sure what
Text string.
if it's like a three code combination lock or something like that, you might need multiple integers. So what else could we use here?
Make it varchar.
Varchar, yeah. So if we had our combination like this, that, I know there's no 3 digits usually on combination locks, but something like that, we can keep that as a string pretty much to keep track of that. Okay, so let's say the number kind of already gives the location, so we don't need to know, or we can actually say floor. So what floor this yeah, let's make it an integer. So what floor this locker is on. Okay, so student and lockers. So we know that each student will get 1 locker, correct? And 1 locker will be assigned to 1 student. So what type of relationship do we think that this will be?
1-to-1.
1-to-1, yeah. Yeah, Zach, do you have a question?
Yeah, I did. And I don't want to derail us too hard. If you don't know off the top of your head, then I can just Google it, I guess. But if you wanted to restrict, like you wanted to specify exactly how many characters the combination had to be so that somebody can't like misinput the combination.
Yeah. So if I know that there's always going to be like a set of like I said, or like I wrote it earlier. So 2 times 3, 6 plus 2, so 8 maybe. We know that all combinations will be that in that style with 8 characters only, then we can restrict it, definitely. Yeah.
But I guess so that's not that's restricting the max, right? So if they were to put in, the first 2 numbers, what
Yes.
happened?
Yes. So there is something, and it is a type of constraint, and it's called a check. So I was gonna use this as like a visual, but we can actually just start writing the schema. So create table, students. I'm gonna. Okay. I'm actually gonna copy the information that I have. Or not, never mind. So ID, we said we wanted serial, primary key. Okay, and then number, we want Oh, sorry, not number. First name. Varchar. Varchar, let's say for a name, we will restrict it to 32 characters because a name will probably not be more than 32 characters.
Then I just want to add that when you put 32, it's actually 33 characters because it goes from 0 to 32.
Say it again.
When you put 32,
Mhm.
it's actually 33 because it goes from 0 to 32.
I'm actually not sure. Let's see.
No, Yaz's logic is right because it's the same reason we do 255 and it's actually 256 characters.
Okay, then yes. Oh, I Googled the wrong thing, but yes, okay. Thank you, Chris, for looking that up. Okay, so birth date, the var, oops. No, it's not. It is a date. And then, I don't know why I did that. Okay. And our last one, okay, we're gonna create locker. Never mind. Okay, so we're gonna create the ID. We said is serial. Primary key as well. And then number, which will be an integer. We can have the number be an integer. Integer. And then combination. Varchar 8 or 12. Let's do 10.
I don't think it likes the word number. I think it's a keyword.
Yeah, I think so.
It's like bold.
Yeah. I think it should be fine. It might be just my interpreter. So my IDE just highlighting keywords. I don't think it will be an issue inside of Postgres.
This is
Okay.
a small detail, but in the date on line 12, you've got it lowercase, but in the visualization tool, you had it capitalized. Do things like that matter?
They do not. So a lot of people tend to capitalize keywords when they're writing SQL, just so it's easier to read. But the actual interpreter, like the actual thing that goes through your code and reads it, does not care about capitalization at all. The only time you care about capitalization is if you are looking for something like a keyword like, and then you have a string, and then if you capitalize something, then it will look specifically for the capitalization.
Thank you.
Yeah. Zach, what were we checking for? Was it the combination, right?
As far as the keyword goes.
For checking like.
Oh yeah, to make sure they put in like the exact number of characters that we're looking for in the combination.
Yeah, I don't know the exact syntax, but there is something called a check. And you can do a check on, this is a type of constraint. So you can make sure to check that this, whatever condition you put on it is correct. So I would have to look up the exact syntax for checking the length of a string, but let's say we're checking that the number for the locker is not over 1,000. So check number does not is less than 1,000. So you can do that and it will add a check to what is it called? And it'll raise an error if it is more than 1,000. I also provide more documentation in the lesson today. So
Awesome. Yeah, I think it's just length. After looking it up, it's just check length
yeah,
equals whatever.
like this.
Yeah, yep. So yeah, I guess on line 4 it would be check length combination equals.
Yeah. So that would be what we're looking for. Thank you for reminding me about the semicolons. Yeah. Jason, yeah.
Yeah, so I was just looking at the Postgres SQL documentation for
Mhm.
number. So it shows number is a keyword, but it says non-reserved. So I was just wondering what the difference between reserved and non-reserved keywords are.
I believe reserved you cannot use. Non-reserved is they have a specific use, but you can also use it in other cases. That is my immediate guess. I would have to look it up to like 100, like double check 100%. You can't quote, don't quote me on that. Okay. Okay, so let's do more than like 4. I don't even know if this would be valid because I think lengths might only be for bar chart, but yeah, let's do that. Okay. So I'll change that to 10. Okay, so we have we're creating our tables. Let's kind of go down the list of these and see if we should allow these to be null. So the ID, because it's a primary key, it is automatically not null. So we don't have to set it here. So that's another feature of having a primary key. It is unique and it is not null. So it is required to have when you are inserting a row. But because we have serial, that means when we're inserting a new record, we do not have to explicitly identify an ID. We can just, when we're inserting, we can just add a number and a combination and it will work. Okay, so number, if a locker does not have a number, we can't really have a locker without a number. So let's say this one is not null. What about the combination?
It can be null, right?
Can be null? Okay, why would that be?
If there isn't a student with a locker or just an empty locker.
Okay, so maybe.
Well, the locker is still gonna have a combo, right? Regardless of the student assigned to it.
Yeah, so if the locker is built in with a lock, then we would have to say that it has a combination regardless. So you would have to put not null. But if it's one of those lockers that you have your own lock that you hook into, then we can allow not null because some lockers just don't have a lock. So that this comes down to a design decision based on our actual data. So let's say for now, we can allow nulls. So when we're inserting, we don't have to insert a combination, but it would be nice. Okay, so let's move on to students. So we have our ID, primary key. We said we don't need to put not null because it is already implied. What about names?
Those can't be null.
Mm-hmm. It would be kind of weird to have a student without a name. Not null. Birth date, I assume it would also be not null for the school's records. Oh, I think I should put the not null part after the date. That's my bad. Okay. Okay, so now we want to give a student a locker. We want to assign a student to a locker. And this will be a one-to-one relationship where, yeah, we want to, if the student has a locker, then only that, like that locker will only be for that student. How can we start this off? So what can we identify a locker with here?
Locker underscore ID.
Okay, locker ID. Okay, the locker ID, and this locker ID is going to be of what type?
A unique foreign key.
Okay,
I'd argue integer.
what type? Yeah, yeah. So an integer.
Integer, yeah.
It will, so yes, it will have to be unique. Why is that?
It's a one-to-one relation. It's
Mhm.
you can only have one locker per student.
Exactly. And how can we say that this will be, so this locker ID will be a foreign key attaching this to a locker?
So you could do the reference
Mhm.
lock and then in parentheses ID.
Yep, references. References, okay. So locker ID references locker or not in
No, so just lockers. So it's
lockers, so the table name.
yeah, and then it's referencing the ID for that table.
Exactly. So
For which table?
for this table. So basically what this is saying is I'm going to create an attribute called locker ID. And this locker ID will reference the table lockers. And it will be matched up with the ID from this table.
Saying why must the line 17 include unique? It will certainly be unique on line 2.
So if we don't put unique here, that means that it means that multiple students could have the same locker. There's nothing preventing it from that. So not having the same locker. A student can have 2 lockers. Hold on, I'm trying to remember. So
One student can have 2 and 2 students can have 1.
So
Aren't we just going to be reading a value into line 12 that exists in table lockers?
yes, the unique specifically, I'm trying to remember the phrasing.
I think you're right, Jim, but it would block it if another student had it already, is why you would put unique. But you're correct.
So at the start of the year, the school secretary goes in and they add all of the lockers. There are 100 lockers. Now you're adding a student, and I would expect that student is the administrator is going to pick the lockers that are available and assign them to a student.
Yes, so without this unique here, there is nothing that would not allow another student from having that same locker ID.
I understand.
Yeah, so we want this unique. We want only this ID to be with this student, pretty much. So the student ID or the student locker relationship will become like a one-to-one, like a true one-to-one. So that is how you can say that how you can implement a one-to-one relationship is having a unique reference, a unique foreign key, pretty much, to an entity, and this will make the relationship be one-to-one.
So what if you were to change that and add the student ID in the lockers table instead of the locker ID in the students table?
So student ID in the lockers table here, because some lockers will, I mean, you could. Yeah, it could be done either way, but as long as you have it be unique and you have a foreign key, then you're good to go. So you can have a student ID here and have that be a unique student ID that references the ID of the actual student. Yes. Okay, Louis? Your voice is cutting out.
That was me, but what I was trying to say is like, so every single time we reference something, is unique always, like, is the most always used with the reference? Like, every single time we use reference, are we always going to use unique?
Unique is used with reference when you're trying to make a one-to-one relationship. You can use unique in other places. So if you're doing like a sign-up sheet and you have usernames and passwords, if you should make the username unique, because if you have multiple username or the same username but different passwords, then you're going to have trouble figuring out which password to check against once you get to that username. So unique can be used without the foreign key reference, and the foreign key reference can be used without unique. So they're not always coupled, but you can use them together to denote a one-to-one relationship.
But most of the time you will want that unique with the reference together though. Or is it just in this, situation?
Yeah, so this is if you're doing a one-to-one relationship.
Okay, thank you.
Definitely. Okay, so we have created this and then one-to-one relationship. Okay. So what else can we have in a school? Maybe we have professors. So create table. Professors. What will this professor have? Probably the same information here, right? ID, first name, last name. Maybe we can also have when they started. So start date is a date. And let's say the start date is not null also. And I'm going to remove that trailing comma. Okay, that's the only one that I have. Okay, any questions about that? This is just, it's just a professor table. So it has some information. Another table that we can create is courses. And what can we have in this course?
Zainab, as a follow-on to what you were showing us, could we also include that professors have offices and 2 professors can share one office? Only 2 professors can share one office.
Let's get back to that when we finish the the schema.
Your course names.
Course name, yeah. So name will probably be varchar. Not null. I guess I should have asked, but I'm assuming that the name for a course should not be null because that's usually used to identify what the course is. What else can we have?
Subject, by chance.
Subject. Oh, so the name is yeah, I guess like maybe description. So the name would be what class it is, and then maybe the description can be just a general description. So since we don't know how long the description is going to be, what kind of type should we have? A text, yeah. Okay, and then also we can have credits. How many credits is this worth? There's a type called small int. So I know that credits will probably not be more than 4 or 10 maybe. So a small int would work. I'm not sure exactly how big a small int would be, but I'm pretty sure that the credits would be covered with this.
Would that take into account like half credits?
Say it again?
Would that take into account half credits in some courses?
No, I don't think so. I think with that, you would have to use a float or a decimal, whichever one Postgres supports. Yeah. Should we have this be null?
I just want to toss out small int goes all the way to positive and negative 32,000. So it's not that small.
Not that small at all. Nice. Good to know. Good to know. Okay, so we can do that. Should we allow the credits to be null?
No, I don't, yeah, not null, because
Mhm.
you have to know how many credits it's for each board.
Exactly. Okay, so let's say for our professor course relationship that only one professor can teach a course, but multiple courses, or so a professor can teach multiple courses, but each course has to have one professor. What kind of relationship would that be?
One to many.
Yes, one to many.
Jada,
Where's
why would you make this into a separate table to have a professor and courses relationship table?
Why wouldn't I, you said, or why would I?
Why would you not?
Because a one-to-many relationship can be done with just these tables. We'll see in the next example that like with the many-to-many, then you have to create a separate table for that. Yeah.
Okay.
So where is the one and where's the many?
The many is on the professor.
Mm-hmm. Okay, so because I think it's
one professor can teach many classes.
Yeah, professor can teach many classes. So because a professor can teach many classes, we won't put our attribute that holds that link in the professor. We're going to put it in the courses because each course will have only one. So this is where we will hold our professor ID. Okay, so this professor ID, what type would it be? What type is an ID?
An integer, right?
Mm-hmm. Yep, integer. And should we allow it to be null or no?
No.
Why not?
Because each professor that's working there is gonna need an ID once they start working.
So this not null does not apply to the professor ID specifically. It applies to the course having a professor ID. So for a course to exist, you must have a professor.
Okay.
Yeah. So this not null is for the professor within a course. So we don't want to allow a course to have no professor. Yeah, Chris.
I just don't know at all, because I have no experience, but is it like a bad practice in this case, for example, if you had made it nullable, would you have like a professor ID be like a placeholder ID? You know, like professor IDs, 9999 is Professor TBD or something.
You could. So you would just remove this not null. It could be null, or if you wanted not null, and when you're inserting, if you don't have a professor, you can have like a specific value that you know in the database.
An unassigned name.
Yeah.
I just didn't know if that was like something that'd be frowned upon, because I think that leads to a lot of errors sometimes when you get like that email to like, email user, and you're like, hey, that's not me.
Yeah, I think I've gotten email like dear null before, which was funny. Yeah. So in that case, there are some cases where you would want this to be allowed to be null if maybe the school administrators create the courses before they assign instructors to them, then they would want to allow it to be null. So then when they assign the instructors to the courses, like they can do that at a later point, and they don't have to assign them when they're creating the courses. Yeah, Yazid.
I'm trying to understand the explanation you gave Kayla earlier. You said the professor ID is not linked to the professor table. How come? How will we know who is teaching that course?
So it's not connected. So the not null here refers to the fact that you cannot, when you're inserting a course row, if you have not null here, that means you can't insert a course without having a professor ID in that data.
No, but you were saying that that professor ID in the table courses is not linked to that ID in the professor table.
It will.
Is it or is not? Okay.
So it at this point it is not, because we didn't link it.
Okay.
But it will be, yeah.
Gotcha.
Lewis?
Yeah, I was about to say, like, what if it's not too much, what if, like, let's say this professor gets sick and we need to call a substitute teacher instead? How will we go about that, and what will we put the substitute teacher? Will we also put a substitute teacher in the courses, but without the null, with not the null? Or how we go about that?
So I assume when the courses are created, they're not going to really care about the substitute teachers. They're going to kind of assign courses to instructors that exist and are on the payroll. And then if a temporary instructor has to take over, they probably will not change anything in the database. And if they do, they could have a separate table for temps, like maybe temporary instructors, and they would have the course ID and then the temporary instructor ID. And that could be a separate table to keep track of it. But for this, we're assuming that this happens when we're creating a course. And when we want to create a course, we have to assign a professor to be in charge of that course, pretty much. Yeah. So yeah, like we mentioned, this is not linked yet. So how do we link this?
References, professor, and then parentheses ID.
Okay, so we reference the professor's table, and then we are linking the professor's ID or professor ID to the ID here in the professor table. So now this is linked. And why is this a one-to-many relationship?
Because a professor can teach multiple courses.
And what allows that?
It's not unique.
Mhm. Yeah. So if there was a professor, like if this professor can only uniquely be in this course, then it would be a one-to-one relationship. But because we don't have unique here, this allows multiple professors in the courses table to be inside of this professor ID. So this comes down, it's you know, like a regular table. Just gonna see if I can annotate. Yeah. So this is a regular table. If we have, this is like professor ID, and this is the courses table. Okay, I'm just gonna put C for courses. So if we have unique, that means that if this ID is up here, we can't have it anywhere else in this table, which is why it works for the students and lockers, because we only want, if a locker already belongs to a student, we can't allow it to belong to another student. Versus here, if a course has a professor, we can allow that professor to appear in that table again, but for a different course. Make sense? Yeah, okay. Let me just clear this and do that. Okay, so this denotes a one-to-many relationship. Okay, so this all looks good here. What about students and courses? So a student can take many courses, and courses can be taken by many students. So this will be a many-to-many relationship. Why can't we just have like add up here? Why can't we add course ID here? And then maybe student ID here.
Is it because of the order that we're creating these tables?
Not necessarily. So, I mean,
Because students can take
Yes.
multiple courses.
yes, and what will be the issue here? If
There's
students
only
can
room
take
for
multiple-
one.
And multiple columns.
Yep. Yeah, so if we know that like a student can take many courses, we're not gonna do this. We're not gonna do course ID 1, course ID 2, and keep going like that, because we don't know how many could happen. It could be there. Same with the student IDs. So a course can have many students, and we're not gonna make a set number of columns for all those students. We are going to create something called a join table, which is just a fancy word to say it's a table that allows a many-to-many relationship. So it is kind of, it's just basically a middleman between this students and courses, and it links the two together in a way that allows a many-to-many relationship. So how do we do that? So we can call this table enrollments. What would this enrollments have?
So as to avoid using a primary key, could you use both the student ID and the courses ID each as primary keys?
We could, yeah, definitely. So we could have a primary key that is just an ID, and then we can have our student and like student ID, and then course ID, but we could also have the primary key, both of these be primary keys. So that means that the unique combination of student and course will be unique. Which, let's say we're doing it this way, and I'll show you how to make a unique constraint on both of these, because both of them are useful techniques. So the student ID, this is going to be pretty much the same as the other one. So this is going to be an integer, not null. And how can we connect it to the students table?
References student.id, student parentheses ID.
References students, and then ID. No, you can have multiple primary keys. I'm pretty sure I've done it before. Yeah, we'll get back to this, but you can usually. Yeah, so you can set primary key at the bottom. So this is also something that you can do with constraints. You can set your constraints at the bottom instead of having primary key. You can just say primary key at the bottom after you're done specifying your fields, and then you can put what columns or fields you want to be that. Okay, so this references students. I'm gonna just do the same here. References what?
Courses ID.
Courses. Okay. And maybe we want a grade as well. So grade. Varchar. And then so because we want these to be unique, we can either make them primary keys and not have an ID, or we can, so to make primary keys, the primary key, we can set student ID and course ID in here. Student ID, course ID, this will create that properly. We can also just say unique. So we can set a unique constraint on these two, where the combination of student and course will be unique.
So this doesn't give the latitude then for one student to retake a course, unless we were to change the title or the ID.
Yeah, yes. That is true. Student ID and then course ID, which is a good thing to think about when you're designing your schema, when you're designing your database. But yeah, so this is how you can create a unique constraint on multiple of these.
Now we're using the word constraint, but we're not actually implementing. Because I thought in the code, I saw the words constraints and then setting stuff up. Using it like this is like unique, and then the two there, that just automatically sets a constraint.
Yes. So you can have your constraints set inside of like line by line, but you can also put it at the end.
Cool.
So when you add that the unique constraint at the end, then will we still have the use for the serial ID up there, or?
Yeah, so the ID will be the primary key that, I mean, right now we won't have a use. Maybe there's a different table that later will need like a singular ID to denote an enrollment. Maybe, yeah, maybe there's another table for retakes and it's different enrollments per year or something like that. So that's where it could come in handy.
Zainab, can you go back and talk about lines 37, 38 again? So are those alternatives to each other?
No, so I mean, yes, if you remove this ID and you had primary key be the student in the course, then you can just use that as the unique constraint.
And those need to be, that primary key needs to be declared below the declaration of the student ID and the course ID. You can also, I'm pretty sure you can add them in line here as well. So I'm gonna have to Google it, but I'm pretty sure you can put primary key on both of them. It might come down to Postgres allowing it or not, but I'm pretty sure in a different language I'm able to do that. So same with the unique, you can either put unique here, but you can set one unique constraint. Yeah, no, this is yes. So on these two have to be unique to make sure that we don't have multiple rows of the same student taking the same class. That is why it's unique. Did that make sense?
I'm looking on. Can you repeat the explanation again?
Yeah. So we're having these two unique because per row of data, we want only one row where a certain student is taking a certain class. So if I'm enrolled in CS 101, I don't want another row saying that I'm enrolled in CS 101. So this will make it unique so that each person will only take one course in that table. Did that make sense?
Okay. Yeah. Okay.
I was actually good until that last explanation, because I would imagine you'd have like a list, probably if we wrote it out, let's say you had, Zainab and then CS 101 as like one, as two cells and two separate columns, I guess. But the way you explained it, it sounded like you could only have your name in there once. So I couldn't have like Zainab also take history 101, Zainab taking.
No, so I would only want that combination of name or student to course be like one entry in the table. So I don't want Zainab and CS 101 on two rows.
Okay.
Because
okay. I mean,
each
I'll
row is
wait
one
for how it
row.
goes. Okay. All right.
Yeah. So that can, so if I wanted to allow retakes, then I wouldn't care about this. Yeah. So if I would allow retakes, that means, so with retakes, I could add another field saying maybe semester. So this will denote a specific semester, and then I can have the student ID, course ID, semester combination be unique, and that will allow retakes. Yeah, Lewis.
I just got a quick question. So when we're using the references, students, and then parentheses ID, is that the foreign key or?
Yes.
That's how you do a foreign key?
Yes, this is exactly how you set a foreign key. Yeah. Yeah. So foreign key basically means that my field in a field in my table ties directly to a field in a different table. So when we say references, that means student ID references the ID in the student's table.
It strikes me this can be, so if this could be notably improved or made simpler, if a course name can't ever have the same, so like, how would you enter then this year's expression instance of Computer Science 101, this fall's expression of Computer Science 101, the spring expression of that of this year, and then the fall and spring of next year?
Yeah, so we're not holding on to semesters. That's the difference. So if we were, then we would probably have course and then semester, and yeah, a course and semester becomes a unique ID. So actually right now there's nothing holding us from inserting courses with multiple names, or with the same name, sorry, multiple courses with the same name, because we didn't make the name unique here. So if we had a semester here, we can make the name semester combination unique here. Yes. Good. Okay, I'm gonna try copying these over to the visualization thing. If it doesn't work immediately, I am not gonna care. Oh, never mind. These are only for MySQL and stuff like that. Okay, so in theory, my schema is correct and built. So let me try running it against a database of mine. So I believe I have so in your regular terminal, you have access to drop table and drop DB and create DB. So create DB and then drop DB, and then you give the database name. These you can access just from the terminal without pSQL. So drop DB, I think I have one that already exists called school DB. I'm just gonna rewrite it. Okay. So now I'm gonna create DB, school DB, and then I am going to run the command to run this file against the school database. So pSQL school DB, and I am going to call the schema.sql. We got an issue. The check length. Okay, I'm gonna remove this check because I'm not 100% about the. I'm going to need to drop tables. Okay, I'm just gonna drop the database again because I didn't add drop table if exists, so I can't rerun this. Is there another issue here? Oh, line 5, thank you. Okay, so I have that. Did I miss anything else? Hopefully not. So, create database, and then I'm gonna run command. Okay, so it created my 5 tables. Awesome. And I have some seed data that I'm going to input. Just gonna grab it real quick. Also, how are you guys on time? Is it okay if we take a little bit, just like 10 more minutes? 10, 15, okay. Also, I'm recording it, so if you really need to go, please feel free. Okay, so let's see. So we're gonna insert lockers. So we have our IDs. We don't need to actually insert IDs, so I'm just gonna remove this part. Because why? Why am I doing this?
Because it's already serialized.
Exactly. So we don't really need to care about explicitly adding the IDs. Okay. So we're gonna have, a bunch of lockers, a bunch of students. Let me just make sure that the So this one is number in combination. This one is first name, last name, birth date, and locker ID. This one, first name, last name, start date. This one has name, description, credits, and professor ID. And then this last one has student ID, course ID, and grade. Okay. Awesome. So this is just some information. Let me make sure. Yeah, this is just the description. It's allowed to be null. All right. So I think this is correct. Let me try running this. So I'm going to do the same command. DB, I'm going to send in my data.sql. Okay, so we did 8 inserts, then we did 4, then we did 5, then 6, then 10. Okay, so it seems like it did everything correctly, which is wonderful. It's not what I wanted to open. Okay. So I'm not sure if you guys have seen this, but I think you can drag. How do I do this? There we go. You can drag a terminal up to here, so you can see the entire, have it be the entire screen. If you don't want it just at the bottom, can be its own tab, which is kind of cool.
Zena, I think you explained the insert 08 those numbers, but I didn't catch it. Can you say it again?
Yeah, I'm not sure about the 0 itself. I think maybe this is just maybe errors, but this number is how many inserts it did. So it for this data, so for the first one it did 8 because we have 8 rows. Second is 4. Yeah, so 8, 4, 5. So it's just how many inserts it did. I do have to look up the first number though, why it's a 0.
Gotcha. Thank you.
Mm-hmm. Okay, so I'm gonna open pSQL with my SQL database just to look at it. Was it DT? Okay, so I have these tables. I have courses, enrollments, lockers, professors, and students. Let's do an exercise. How can I grab okay, I wish I had a visual representation of this, but how can I display, I'm gonna put this here. Okay, so I want to display student name and course names for the student with the locker combination this. So let's work together to build it, just because we're kind of short on time. I'm gonna make my queries. And then I'm gonna open a new terminal just to, actually, I'll just drag this back here. Quit. Okay. So how can we start building this?
Select student dot name, comma course dot name.
So let's start one thing at a time. Let's say we have our locker combination, right? So we can probably grab all the information about so we can grab all the information around something with a locker combination here. So let's select star from what?
2 lockers.
Mm-hmm. What's the condition?
When
Where combination equals.
Mm-hmm. Combination equals, is it 1 equals or multiple, or like 2?
I think it's 1.
Okay.
Oh,
So let's try doing this. So select star from lockers where the combination is equal to this.
Semicolon.
Semicolon.
Oh, semicolon, thank you. Okay, so we have an ID, we have a number, and then we have a combination. So we want student information, right? So how do we grab student information as well? I'm just gonna put multiple. So how can we grab information from two tables at once? What is
Join them.
Join, yeah. So we're gonna start with lockers because we have the combination, right? And then we can say join what table?
Students.
Okay, students. On what? So join, you have to add join the table and then on a specific condition. So how are these two tables connected? Do you guys know?
Students dot locker ID
Mhm.
equals lockers dot ID.
Students dot locker ID equals, what was it? Locker
Lockers dot ID.
ID, okay. And let's see what this does. And then I put a semicolon. Okay. What did I do wrong? Is it in the data? So the students, no, students are, yeah, the locker ID is connected to locker. Okay. For some reason, this locker became an ID 7 and we don't have an ID 7. So
16, 26, 36.
what is it?
I think just change the 7s to 6s in the query or the where.
Okay. Let's do that. Whoops. The 7s to 6s, you said, right?
Yeah. Yep.
All of them?
Yeah.
6 and then 6. Okay. There we go. Okay, so we have this person. And so now we have all the information from both tables. We have, okay. So typically when you're doing a lot of joins, you want to give the table an alias, so you don't have to write the table name every single time. You want to specify a specific column from it. So I'm going to give lockers L and then students, I'm just going to say S. So I can say s.locker_id equals L.id. So this just makes it a little easier to type the queries out. So we want the student name. So let's say s.first name, s.last name. And we haven't gotten to the courses yet. Okay, but we have the student information based on the locker ID. Okay, so let me just make sure that this works. Okay, so we have the first name and last name correctly being added there. Okay, let's look at our schema again. So our student and locker, we've already joined them, so we got the information for the student. So how can we jump from students to courses? What is the table that, let me make this a little smaller. I don't know if that helps or makes it worse, but how can we jump from student to courses? What's the table that connects the two?
Enrollment.
Exactly. So enrollments, so we pretty much want to find a path from when we're writing these queries with joins, we want to find a path from the information that we have to the information that we want. And a lot of times you have to just start joining one table at a time, and then you'll start grabbing the information one step at a time. So this is how I would recommend writing these joins. So we want to join enrollments, right?
Is it pretty normal to be in the middle of trying to make a query and then realizing like, hey, this information I'm trying to put out actually isn't connected anywhere, and then go back in and create a schema that does in fact connect them, and then at that point be able to,
Yeah,
like, does
it's
that
very possible.
stuff happen?
Yeah, it is possible. So sometimes you will create a table that you will grab from. So there are nested select tables. So you can join. I forget the syntax, but you can add like a select statement within a select statement. It gets a little more muddled, but yeah, we'll I can find resources for that if you're interested. Okay, so enrollments, E on what? What's connected to the enrollments? Which table?
Students and courses.
Students and yeah, exactly. So which one do we have access to here?
S.
So S dot what?
Courses.
Can you does student have courses? So student has an ID. So what connects the enrollments to the students?
The student ID.
Student ID on the enrollment side, and then ID on the student side. So we're gonna say, we can say E, it doesn't matter the order. So we can say E dot student ID. So enrollment dot student ID equals S dot ID. So this now will connect our enrollments to our students. And now we have access to the enrollments. So we can say, let's just print out E dot star. So this is E. So all the columns inside of E. Let's just print them out as well. See what we have. And now we have the name, we have the ID of the enrollment. And then we have student ID, course ID, and then grade. So now we know that we have access to the course ID. What can we do?
A join.
Add another join. And what can we do or which table are we joining?
Courses.
Courses C on what?
Couldn't we do, what would that be? Enrollments. ID equals, or no, enrollments, course ID equals courses.id.
Yep. Equals C.id. And this will connect the course that we want to the course's ID in the enrollment that this student is taking based on the locker combination. So now courses and then courses. So we know that we don't really need anything to display on E because we're displaying the student name and then the course names. So what are we printing out here?
You can do a C dot star, right?
Yeah, so we'll do C dot star first because we don't really know what we want to grab. Awesome. So this student is taking this class, and if we want just the name, what do we put up here?
C dot name.
Exactly. And we grab, put it here. There we go. So now we have a student with a name and or student name and the course name that they're taking. So if there was another, let's say we can add another enrollment. So enrollments, what is Cassie's ID? Let's see. Cassie's ID I actually don't know. So how do we know Cassie's ID?
You can put in an SID.
Yeah. So s.id. So we'll find out that Cassie's ID is 3. So we can create an insert query. Where is it? Or an insert statement. Okay, so her ID is 3. Student ID is the first one, so she only has 1. I'm actually not gonna run the entire thing because those already exist, but I'm gonna say I want to insert student ID is 3, class. If I insert this class, what do I get?
An error, right?
Huh?
An error, because it's unique.
Exactly, because we put in our schema here, we said that the student and course ID combination is going to be unique. So if we try to insert 3-1 again, it will give us an error. We're not going to be able to do that. So let's just say we're going to insert 3-2, and the grade is null because she's currently taking this class. So I'm going to copy this information here. And I'm going to run this insert statement. So the way we write an insert statement is, I don't know why it's not on highlighting. It's a little hard to see, but insert into table name. And then you specify the fields. So we have student ID, course ID, and grade. So this is the exact order in which we're supplying values. And 3 is going to go under student ID, 2 is course ID, grade is null. So let me do that. The insert went through. So now if I run my command again, so the lockers one, now I have 2 because we have different courses that she's enrolled in. So this will grab all of the records that we have. What if we only wanted 1? Great question. Oh, sorry. So if we only wanted 1, we can write limit 1, semicolon, and it will only give us the first record that it finds. So you can limit how many records that go in.
Is it true then for like a select all on a huge database, that's where you could do this, use the select all where it only limits like a certain amount, so you're not like eating up a bunch of the memory?
Exactly. And it takes a lot of time sometimes. If you're like grabbing all of the records in a database, if you have like millions and millions of records, you can do a select star, and then you can do from whatever table you want, from table limit like 1,000 or limit 100, and it would, yeah, it would be good for exploration. Okay. Oh my God, it's already 12:36. Okay. Questions?